screen so that Monica can take over. And Monica, whenever you are ready, feel free to share your screen and get started.
Great, thank you. Let me get the right window shared here. All right, well, thank you so much for having me and for joining. I know everyone has really busy schedules, so I'm really honored to be here talking about the vision for AI and harnessing AI to advance the Weather Service mission and transformation. So in this presentation, I'm hoping to give you a broad overview of kind of all the different things that are going on. If you have specific questions on anything, I'm happy to follow up. As a brief introduction, because I don't think I have had a chance to meet a lot of you, I'm Monica Youngman, and I'm the Chief Scientist, and I sit under OSTI, and I lead AI for the National Weather Service, and I also serve as the chair of the NOAA AI Executive Committee. I joined Weather Service in February, but I've been with NOAA for 15 years. My educational background is in physics and environmental economics, and I've been at NWS, NSDIS, and now the Weather Service. So I'm very excited to bring kind of my diverse experience to the Weather Service and to this work. So AI is a tool, right? It is just a tool, like any other tool. Right now, it's getting a lot of press and excitement. But before jumping into the vision for AI, I really want to focus on why. Why are we excited about AI? What can it do for us? And when I joined the Weather Service, I didn't realize that I would have a very relevant personal story, but I'd like to start off there as leading into that why for AI. So I live in Asheville, North Carolina, in Western North Carolina, and in September we went through what was then Tropical Storm Helene, and I'll start out by saying my family was very lucky. Our house was not damaged, our cars were not damaged, and we are all safe. But these are pictures from my neighborhood. So in the upper left, that's a tree that fell into our neighbor's yard. In the upper center, that's a house, one of our neighbor's house, that was crushed by 3 large oak trees. They survived, but they had to be cut out of their home. This was after they removed the trees. Cars crushed, our road was completely blocked. So we spent 2.5 days not being able to leave our neighborhood, with no cell service, no internet connection, no water, and no power. This event has really shaped how I think about what we're trying to do at the Weather Service and with AI. So what was most challenging for me as I walked around the neighborhood talking to people when we had no connection to the outside world was that people said that they didn't know that this was coming. The models and the forecasts were very good. We knew at least 72 hours in advance that there would be major impacts in Western North Carolina. That information was there. And so when I heard my neighbors saying, we didn't know this was coming, it broke my heart. That what are we not doing that we could to communicate this, to help people understand the risks, the uncertainties that we know are inherent in forecasts and the possibilities. So this isn't just people's lives, and our neighborhood was lucky. We didn't experience the extreme flooding that they saw in Swannanoa just up the road. So this is an image of the flooding around Swannanoa. Normally this river is at 2.2 feet and it crested at 26.1 feet. People were on their roofs and got swept away. Their houses completely destroyed, even if they survived the flooding. And in this case, the flash flood warning came at 5:38 a.m. The mandatory evacuation notice was at 6:15 a.m. By the time the mandatory evacuation notice came out, people's cars were being flooded. They couldn't leave in many cases. And the river didn't crest until 3:45 p.m. So I have a friend who experienced this and barely escaped with her life. And so it was not only extreme weather, but there were very diverse impacts between trees, flooding. I have another friend who almost lost everything due to landslides and mudslides. And then it's not just people, but businesses. If you're familiar with Asheville, this is the Biltmore Village area. It is a tourist area that is one of the economic drivers. It supports jobs, it supports the economy here, and it was completely devastated. If you look on the upper left, that's one of our favorite Indian restaurants, and you'll see on the awning, there's the high water mark. And these are pictures I took 5 days after the event because I couldn't get down there before then. So a lot of these small businesses may never come back. You know, they've pledged to rebuild, but some of these will not survive. So how do we take our models, our forecasts, not only continue to improve those, but make them matter to people and their decisions? So this example that I lived through is only one example of the more frequent, more extreme weather events that are really pushing and challenging our models and our community's understanding of their risk. So the challenge is, how across the Weather Service do we address this with a limited budget, with overworked staff? We're all extremely busy, and just this greater demand for information and tailoring that. And so that is where I see the opportunity for AI to be used. So there's no amazing way to transition from that story, but before, talking about how we can potentially leverage AI to address these challenges, I'd like to step through and just kind of level set, what am I talking about when I talk about AI? Because there's many different definitions and it gets thrown around. So let's see, some common terms. Artificial intelligence is a very, very broad term. It's really the field of studying and making computer algorithms that exhibit human-like intelligence and behavior. I will say exhibit, that's really the key word there. Right now, we're not to the technology that really has intelligence itself. Now, artificial intelligence, that's very broad, and it includes things that we've already been doing since the 90s. Machine learning is part of that. So in the basic form, this is just regression. But then we get into more advanced AI methods, so deep learning, using neural networks, and then generative AI, which is about creating things that didn't already exist. So I'll go through a few examples here. So what is a neural network? Because this term gets thrown around, and I like to show this slide because it shows how these were built on the human brain. So on the top, you see the human neuron, a cell in our brains, and then this is an image of the collection of those neurons in our brains. So AI, a neural network for AI, is designed the same way. It has a neuron, it's some function that's a weighted sum of inputs, and it gives an output. And then you connect all these together and train it so that each of these nodes is factoring in different weightings, and it puts out an output. So that's what we mean when we say a neural network. And then generative AI. So a lot of times we hear of large language models. And it's really just guessing the next word. It's an algorithm that's been trained on the human language, mostly English, and it guesses the next word. And it does typically a really pretty good job of it. But this can create things that have never existed before. And so on the right, you'll see ChatGPT asking, we ask it, create a brownie recipe in the style of a Shakespearean sonnet. So it knows what a brownie recipe it is, and it has, seen brownie recipes and it's seen Shakespearean sonnets, and then it creates a recipe like a Shakespearean sonnet. So that never existed before. That's why it's called generative AI. I can't guarantee that recipe is any good. I wouldn't try it, but there it is. Now, when we say generative AI hallucinates, it can mean a variety of different things. One of the examples I like to give, and it's a little bit easier with a live audience, but what is the next word? Duck, duck. I usually have people shout it out. What's the next word? There's a variety of answers, and I happen to be from Minnesota, is where I grew up. And for me, I say gray duck. And a lot of people say goose, as we have in the chat. So I don't know if there's anybody else out there from Minnesota and grew up with gray duck. But if someone is used to duck, duck, goose, and a generative AI system comes back with duck, duck, gray duck, you could say, hey, that's a hallucination. Whereas I would say, well, that's correct. So we have to be a little bit careful here about not only how we train these systems, but how we test them, and decide what is a hallucination. So a little bit more about hallucinations. All this is a prediction function, right? We're predicting it. And so, you can kind of think of, if the black line is the target function, that's what we're trying to get to. But if you only give it the blue data, those blue dots, as the training data, it's going to learn something that's similar to the green line. And that's what it's going to predict. So it won't predict the black line, and then it'll look like it hallucinates and is wrong. So that's really all it's doing, is because it's predicting the next word. One really strong example, and I love DuckDuckGo too. That's another good example. One example here is that if you ask ChatGPT for references, it will make up scientific papers that will look completely valid, be formatted, maybe have names of people actually in that field, but they don't actually exist. So we have to be really careful on, validating output from large language models. And then this is the, my required CYA move for everyone, generative AI guidance. So we'll see how this changes with the new administration, but DOC in the last administration put out an interim generative AI policy that basically said you can't use generative AI outside of approved pilot projects. So you can't use it for official business with non-public information. It all has to be public data and on any government equipment. So this includes ChatGPT, Copilot, note-taking, and capabilities built into third-party softwares which can be really sneaky and show up. Now, there are pilot projects that are approved. There's a NOAA group that manages that approval process. And so we can get pilot projects approved. I am trying to coordinate so we don't duplicate efforts across NOAA. For example, there's already existing pilot projects on like note-taking and some of the other kind of administrative benefits that we can get from generative AI. So if you're interested in those, I could potentially connect you with the existing pilots rather than creating a new one, which removes the whole approval process. So just be very, very careful on using generative AI. And stay tuned as policies may change and things may change there. So with that, trustworthy AI is a big buzz term. And the community is really figuring out, what does it mean to have trustworthy AI? And there's a number of aspects here. One is, first of all, you have to build a system in a trustworthy way. It's, what are your model choices? What's your training data? How do you design it? And then it's, how do you make it trusted by the users? And that is really more of an engagement, of a learning process, including those users in the development decisions, in the testing, and the continued maintenance, because things can change over time. And if the AI system is not continuously trained and updated and maintained, it could, produce erroneous results. So there's a lot of discussions going into what that looks like, and particularly within the Weather Service, how do we ensure this for our AI projects with the limited budgets that we have right now. I will also highlight that there's a number of executive orders and OMB memos that are, broadly cover safe, secure, and trustworthy AI. And NIST has a risk management framework. So these are all things that we're looking at to try to leverage to build trustworthy AI and do that well. The European Commission also has an AI Act that talks about risk and how much risk is acceptable to take and in what way. So lots of different things going on, but a lot of the work is how do we translate these frameworks and ideas into really tactically, how do we make AI systems and the individual projects that we have trustworthy. So let's talk about the NOAA level first. We do have an artificial intelligence strategy for NOAA. This was written back I guess the date is 2020. I think it was written 2019. And it has these 4 pillars. I'm not going to go into this in depth because we are actively writing as part of the NOAA AI Executive Committee the next version of this. And this is for a number of reasons. One, when this was written, generative AI didn't exist. It wasn't a thing. And so this current policy is very focused on environmental applications, which have not gone away. And we really need to update it for all the generative AI applications that's going to touch everyone in the organization, whether you're in modeling, forecasting, HR, budget, just the whole gamut. Communications, like all of it, is going to be affected with generative AI now. We also wanted to connect the new strategy very closely with the data strategy, cloud, and HPC, high performance computing. So all those other 3 are also getting updated alongside the AI strategy so that we can really integrate the messaging and the approach across NOAA. Oh. There we go. I didn't mean to click the link. All right. So a major player across NOAA is the NOAA Center for Artificial Intelligence. So this is a tech hub that is working to promote ethical AI innovation, and it really focuses on 4 different areas. One, again, training responsible AI, trustworthy AI. A lot of times these terms are used interchangeably. AI-ready data standards. So AI needs a lot of data, and it needs comprehensive and representative data. So how do we get those data sets ready to be used in AI, not only for our own use, but released publicly for the whole community's use? And then there's partnerships and engagement and communities of practice and that coordination. They do have a Slack channel to be able to, help practitioners across NOAA answer questions, learn from different groups. And so if you're interested in that, I can always connect you in with that community. So as part of NCAI, they do have what's called learning journeys. These are examples of AI projects that have been developed across NOAA. So they include not only the code and the data sets, but it's a platform where you can actively run it and learn from what other people have done, they have done. Yep. So here are some examples of the current learning journeys that exist. So we have them on lightning, tropical cyclones, magnetic navigation, ocean acoustics, and rip currents. So these are available, and previously there had been some live walkthroughs of these learning journeys that may be offered again, but they also exist that you can step through on your own time. So just briefly, the organization chart of what this looks like at the NOAA level, the NOAA Science Council and the ASEOP, the Assistant Secretary for Environmental Observations and Prediction. gotta have that acronym right, are the champions of AI across NOAA. So right now, the acting ASEOP is Dr. Steve Volz, the NESIS AA, because the political position is vacant until an appointee arrives. So we have the NOAA AI Executive Committee. This is representatives from across all the different line offices to really guide and inform the strategic direction for NOAA and inform the NOAA Center for AI. So Rob Redman is the director there and is leading this with a very small team, considering he's trying to work across NOAA. And then we also have an AI working group with some folks from Weather Service. So these are folks who are developing an AI and want to learn from others who are doing similar work. And then the generative AI working group. So this is the group that is managing that generative AI pilot project approval system under the Department of Commerce interim guidance policy. So now we've gone through the NOAA level, let's go to Weather Service and what we're doing. So really, the goal here is to enable the Weather Service transformation by enhancing the accuracy, the efficiency, and the community-centric messaging of our products and services, and enabling us all to really enhance our ability to fulfill the mission. There's a number of current actions. One is developing an AI roadmap, and I'll show a diagram on the next slide of the draft there. And then trying to get some early collaborative wins, some really small AI projects launched where there's gaps, where things are not yet occurring, and then trying to work and build enabling services. So this is the draft structure of the AI roadmap. The document will go into more details in each of these areas, but this gives you a sense of the scope of what we're talking about. So a lot of times when people think of AI and weather, they think of modeling. And there are a lot of opportunities with AI for weather prediction and for data assimilation. And I really like to emphasize that this is one component of the weather value chain. And there's a lot of other potential for AI to be used to help our operations across the entire value chain as seen here. So the green box with data assimilation and weather prediction is also joined by AI to support our probabilistic impact-based decision support services, everything from the NBM to NWS Connect and how we're serving our partners. In the middle, community-centric warnings. Could AI support our goals to really deliver tailored services? Fourth, operational efficiencies. This is about supporting our staff. We're all overworked with too much to do. How do we support what we need to do in a way that gives us more time to focus on the high value things that we need our humans, our people, and our expertise to be focused on? And then finally, software and hardware efficiencies. So this is not only software development, it's also looking at our hardware systems. Could we optimize how those are run or designed? And underpinning all of these, it's really critical, the three enablers here, which are community and workforce training. It doesn't work to just develop AI systems. We need our users, our staff in the Weather Service and our external users, whoever that user group is, to be involved, to be informed, to be able to contribute to the ideas and to the development and to the testing. Then there's data management. Data is critical for AI, not only to make sure it's doing what you want, but making sure it's not discriminatory or leaving out certain groups or aspects. And finally, technology infrastructure. Right now, the cloud is the big one, but there's other aspects there with how do we get the right data management systems on the technology side. All right, so I won't step through this, but I'm going to go through a few examples in some of those different categories of kind of what's going on right now. So the AI for weather prediction value chain, there's a lot going on. And there's a lot of different offices involved between Weather Service and OAR. So the work spans these 4 categories: dataset generation, infrastructure development and testing, and then evaluation and R2O. To summarize this, and you don't have to read it all, but really in summary, it's about looking at the AI weather models that are being developed by the private sector and evaluating those, building an infrastructure to be able to rapidly test and figure out what the strengths and weaknesses of those AI models are, and then potentially setting up a structure to build our own in-house data-driven AI weather models or data assimilation systems. Next, and one that's probably more familiar to a lot of you, is the language translation project, which I kind of categorize under this communicating weather hazards under the community-centric warnings. Excuse me. So this uses AI trained by our forecasters who are fluent in different languages to then automatically translate our watches, warnings, and products into currently 5 different languages. And they're working on, I think, adding another 12. I don't have the right time frame. But currently we have Spanish, Simplified Chinese, Vietnamese, French, and American Samoan. All right, the next one, so under operational efficiencies, one of the projects that's being started and just kicked off and is in the early stages of development is how could we use generative AI to help support the drafting of local storm reports. So there's 2 goals here. One is to help our forecasters across the US, save time and not have to, spend as much time hunting for these reports and writing them up. And then second, is if we have a more automated way of doing this, we might be able to capture more and have greater consistency across the country. And so that will help that retrospective look in the storm events database when particularly our social scientists are going back and trying to understand impacts and the effects of these weather events. So this is a collaborative project with AWS. They have volunteered at no cost to help us develop this generative AI system. So we're starting with 4 different sources: news and social media from trusted sources, and looking to collaborate with the Savvy group to do that. Slack, looking at our EM community and posts that they are already giving us, Department of Transportation reports, and then MPing. In the future, we may also expand to, different modes of audio and visual with cameras or images. Next is another project that is just recently gotten started. It's not very far along at all, but it's had a kind of an intro kickoff, a really early prototype demo, which is a Weather Service internal chatbot for documentation. So this is going to be a chatbot that will be referencing the Weather Service directives and the AWIPS documentation. So we're starting small to prove out the concept, to build it, and to be able to connect it into to our Slack system, as well as having it on VLab. Once we prove this out, the idea is that then we would expand that knowledge base that the chatbot can see. So we would add governance documents from NOAA and DOC, and potentially other documentation system. We could add regional documentation to this as well, so we can expand it out after we've gotten that basic system in place and proven it out and tested it. Finally, I'll touch on software and hardware efficiencies. There are active projects in VLab to assist developers in writing software, so you can use some of the AWS tools to do that. And then there's MDL, the Meteorological Development Lab, is looking at getting a project started to modernize legacy code. And so these are both approved generative AI projects that are looking at how do we support our software development and sustainment with AI. Other ideas for the future are, how could we optimize our observing network? So for example, could we optimize our weather balloons? When and where we launch them? Would there be a way to improve the impact of those observations? The second is, could we predict hardware maintenance needs? Rather than trying to do maintenance on a regular schedule, could we have a system that monitors the output, monitors the environment, and predicts when there would need to be maintenance on systems? So those are just ideas at this point, but just want to give you some samples there. So finally, I'd really like to highlight the pseudo generative AI team. So this is a team that was formed just before I started. So they were just over a year ago. And they came up with a list of short-term wins that they would like to see with generative AI. So I wanted to highlight these 5 because it has been extremely helpful to work with this group to hear directly from the field of what's going to be useful. I don't want to be coming up with what I think is useful because I'm not the audience that I really want to serve. And so out of these 5, you'll see the 2 that I highlighted in bold are ones that I've already mentioned are getting started and in the works. But the other 3 are getting a chatbot for the XM ACES climate database to help with our WFOs answering climate questions that come in that people may not be as familiar with those data, and so really to save time there. The third bullet here is determine and or create 508 compliance of graphics and other products. And then the fourth bullet is developing a first guess of key messages from text products or from graphical information. So just ideas on how we could support our staff, not a replacement, but how do we help them save time to meet the greater demand that we're all feeling. So that's a summary of kind of what's going on within the Weather Service, both from a strategic perspective with the AI roadmap and these individual projects. I want to step back for a moment and imagine what we could do in the future. What could AI enable? And AI is a tool, so it's not the magic wand that is going to make these things possible, but it could enable these things to happen. And these are just my personal, ideas. That this is not anything official. But first, the resilience. As our communities are facing things that they've never faced before, it is very hard for people to understand that. I can tell you here in Asheville, if you told people that our rivers would rise to 26.1 feet, they didn't know what that meant. Okay, that's a lot of water, but it's so hard to have that sink in. In fact, I had people who own businesses along the River Arts District, so it's along the French Broad River, and they looked at the forecast, they looked at the models, they knew the predicted rise of the river, and they guessed wrong of where that was. They thought it would only have minor flooding in their business, and instead it completely destroyed everything. And it was an arts business, so their whole business was gone instead of just trying to get things off the floor. So how can we help people understand these? And that visualization, I think, is really key. So we could use AI to combine local digital twins with our weather and climate scenarios. So a local digital twin would say, here's a city, here are all the buildings, here are the utilities, the infrastructures, the water treatment plant, the hospitals, the schools, the fire departments, police departments. Here is the infrastructure, and not only where is it, but how are these things related? So what's the power grid that feeds the hospital? What's the stormwater system that, how is that connected to the rivers and streams? So you have that digital twin of that data and the interconnectedness of that data, of those data. Then you take the weather and climate scenarios and visually put that into the system. and show people what will this look like, and we can communicate the best case, worst case, most likely cases, and not only show people what could happen to better understand and comprehend the impact. It could also serve our local city officials who are, every year make decisions on where do they invest the limited money that they have. So we could play the what if scenario. What if the city put in a levee versus what if they improve the stormwater system? What if we move the water treatment plant or put in a bigger pipe? How does that change the impacts and the outcomes? And so it would help demonstrate the benefit of these different scenarios, which I think is something that we struggle with. We know the cost. We know how much it would cost to put in a levee or to do a stormwater project. But what are the different benefits, and how does that affect the city differently? This type of thing could have saved Asheville from going through 2 months of no water. They had the water treatment plant, and after the last major hurricane came through in about 2005, I think it was, they decided they'd build a bypass pipe for the water treatment plant to make sure there was always water that could flow. And it was a massive pipe. They buried it 25 feet deep, and they said, okay, this is our backup. When Helene came through, it removed the 25 feet of dirt and destroyed that pipe. This was something no one knew that was possible. They thought they had the backup system. And so that meant that the city of Asheville was without water for about 2 months. So that's on the resilience side. On the response side, what could we do? We could use AI to enable integrated, multi-hazard, and tailored public safety messages. One of the challenges that I experienced with Helene was that we got separate, warnings for different hazards, right? There was a flash flood warning, there was the wind, but the impacts and what people need to do is actually the integration of these hazards. They're not separate for the communities and for the people. So could we not only combine the hazards, but also tailor this to the individual and integrate it with state and local information? So could we tell people, not only maybe get to higher ground, but where is that higher ground? Or this river is, there's a flash flood warning. Okay, where are you located? I got the flash flood warnings throughout the night on my cell phone. I had already looked at the flood maps, and we are not at risk of flooding. And so people tend to become desensitized to these messages and ignore them. And when people are really truly at risk, that's very dangerous. So could we tailor these messages to where people are, depending on what information they're willing to share, voluntarily, automatically provide them this information in the language they desire, and combine it with that state and local information. So another example would be which shelters are open and have space, or which ones accept pets. So the resilience and response ideas I have here are, I want to recognize all of this is not on the Weather Service. It requires a lot of coordination and partnerships with our local communities. And I think AI can enable this to happen, and it would have an enormous impact on realizing the outcome that we're really looking for, which is to protect lives and property and promote the economy. Now, I've talked a lot about what we're doing and the amazing things we could do. And I want to introduce a dose of reality, and that it's not all easy and just straightforward to implement. So I want to take a moment and fully recognize that there's a lot of challenges we need to address before we can just charge forward and make amazing things happen. So one is culture. There's a lot of fair perception of and that trust in AI, where there's a lot of fear there about what's happening with AI, as well as a fear of change. You know, if this is going to change people's jobs and their roles, that's understandable. And there's a couple things I want to say here is one, I think the skeptics and those people who don't trust AI, those are important voices in the room as we develop these AI systems to make sure that we hear, we listen to, and then adjust. How do we build that trust as we're building these AI systems? And that's about people. It's not just about technology and code development. The second here is about losing my job. My goal with AI across the Weather Service is to support our staff. I want to hear from you what is going to help your job, your role, and what you're doing for this country. This is not here to replace jobs. So I can say that, and I know that there's a number of people that are not going to believe it, and so I want to do it through our actions. And so the approaches that I'm trying to take are really to listen to the users and have our projects reflect their needs, include those users and stakeholders in our development process, and then many of these systems, we're going to have a human in the loop. So for example, with the local storm reports project, that system design will only draft a local storm report. We need that final check by the forecaster before that is finalized. So in the future, there may be more automated systems, but right now we absolutely need the human in the loop. Second, there are administrative challenges. We don't have an amazing new pot of money to do this and to use AI across all the different initiatives. So we need to prioritize. We need to find a way to approach these and use those projects to get greater investment. And we also need to find partnerships to advance initiatives. It's a challenge, though. There's lots of people who are willing to engage and partner, but then we need the bandwidth to engage with them. So it gets back to the resourcing. And then we also have evolving policy. So particularly around generative AI and with the administration change, I have no idea where the policy around AI in general and generative AI is going to go. So really trying to keep tabs on that and be able to adjust as rapidly as we can. So the approaches here, I'm trying to start with some small targeted projects. So just within existing resources, within existing initiatives, and measure that return on investment so that we can show the time savings, the cost savings, and use that to get more investment to do more AI and to support our workforce and our mission. And then the second is trying to be actively involved in the policy development so that the policy goes in a way that supports our mission and not, we don't get dictated to do AI in a certain way, and be able to communicate the challenges there. Final category of challenges is technical. So I've already mentioned building trustworthy AI. It's easy to say, it's not easy to do. There's some best practices, but it can be very different depending on the AI system that you're building. There's also IT resources. So at the same time that we're looking at how do we leverage AI to support our mission, we're also migrating to the cloud, which is going to be a foundation for AI. And then we have data management, particularly creating training data. So I'll let everyone know that we are looking at trying to find some volunteers to help create training data for the LSR project, because for AI, you need pairings of inputs and outputs. So for example, we would need an input of here's a social media post, and here's what the LSR would look like written by a human. And then we give those pairings, and then they can train an AI system. So typically we don't have, for a lot of the projects we're interested in, we don't have that training data already curated. And then finally, we really want training for our staff and stakeholders, and trying to figure out how we do that as broadly and comprehensively as possible. So some of the approaches here, leveraging existing groups. So NIST, National Institute for Standards and Technology, their risk framework, trying to leverage what they're doing. And AI2ES is it's a National Science Foundation funded center that looks at trustworthy AI. So I'm starting to get more engaged with them to see how we can leverage their work to support trustworthy AI development. And then second, trying to integrate into the existing IT data and training work that's happening within the Weather Service about how do we make sure it's enabling AI. So finally, I'd just like to end, AI has the potential to revolutionize weather service delivery. So from the research all the way through operations and to the service delivery to our partners. And I think there's a particularly strong potential here to help with the integration of diverse scientific disciplines and to directly connect with people in that individualized way that we just don't have the bandwidth to do. Now, the path to fully realizing the potential of AI is bumpy. It's not a straightforward path, and it's not just about technical development. It's really about engaging people with the AI. So there's 3 bullets here, just to end with, fostering partnerships, across the Weather Service, across NOAA, across other government agencies, our academic partners, private and international partners, I think will be key, as well as developing those foundational capabilities. And then finally, just realizing that there will be problems along the way, and it won't always go smoothly. So trying to advance, that patience, openness, and tenacity. So with that, I'll stop presenting, and I welcome any questions. Thank you for your time.
Thanks so much, Monica. That was really engaging, really awesome information, and what a powerful story with what happened in Asheville. If you do have any questions, we have some time, so please type them in the chat box, raise your hand, or just feel free to jump in as well.
And if there is anybody out there who says duck, duck, gray duck, let me know. I'm still searching for those people.
I actually almost typed that. I'm from South Dakota, but close enough to Dakota that we did say that. Awesome. Thanks, TJ. I appreciate you reaching out and advertising that resource. All right. Well, I'm not seeing any questions. Thanks again, Monica. Really appreciate you presenting to us today. We will make this recording available as soon as possible, hopefully later this week. And we'll advertise that probably in the Slack channel and our Sioux Slack channel when that recording is available.
Sounds good. Thank you, everyone. Stay warm.
Thank you.
Hold up there. Thank you.